Hello everyone, and today we'll be talking about medians, altitude, perpendicular bisectors, and angle bisectors. Now, first let me introduce what are they. So as you can see, the median here is it stems from the vertex and basically splits the opposite sides into two. Now, the altitude basically stems from vertex and form 90-degree angle perpendicularly with the opposite side. A perpendicular bisector bisects a line, which means halves it, and into two sides that are exactly the same, and also form a 90-degree angle, thus the perpendicular. And the angle bisector is when the angle is split evenly into two by this line. And these are the four lines that we'll be talking about today. Now, to utilize an altitude in, a problem, it's one of the most simple ones, obviously, finding the area of a triangle. As we all know, the area of a triangle is base times height divided by 2. Now, if I just write it here, it's base times height divided by 2. And here we can see the base equals to 8, and the height, which is also the altitude, is equal to 7. That by 2 is 28, which is the final answer. This is a very common place that we use the altitude constantly, and it is very helpful because many geometry questions require you finding the area of a triangle, and knowing the altitude really helps. Another theorem that we can look at and solve questions with is the angle bisector theorem, as it splits the angle into two. We can look at, for example, this triangle. So the length here is 8, and this length is 12. This is not drawn to scale, it's just simply for a demonstration. And let's presume this is 16. And now the angle bisector theorem is interesting because it proposes that the ratio of one side of the triangles should be the same as the ratio of the other side of the triangle. So which means is that the ratio of 8 to 12 is the same to the ratio of 16 to x. The ratio of 8 to 12 is the same ratio as 16 to x. And we know cross multiplication, or we simply can 8 times 2 equals 16, so 12 times 2 equals 24. So x must equal to 24. And the angle bisector theorem is interesting because then these kind of problems can go on to solve many different other ones due to their similarity in ratio and can form Hartley equation. Let's say this is actually 12 minus x, and this is x plus 3. And we can still plug it into the equation, except this time we'll just use cross multiplication, and if we times that over, which means 8x plus 3, 24, divided by equals to whatever 16 times 12 is minus 16x, and then you can go solving it by doing algebra. And this is a very interesting theorem that people can use. A very special triangle would actually be the isosceles triangle that I have right here. And it's interesting because this one line that is right in the middle of this isosceles triangle is actually all four of the lines we're talking about. It's a median since it bisects the lines at the bottom into two exactly same distance halves. It's an altitude since it starts from vertex, and it forms a 90-degree angle. And since it fits both of these ideas, it's also a perpendicular bisector, and it also bisects the angle. So it has two angles that are exactly the same from the vertex that it bisect. Isosceles triangles are special triangles due to that this one line is all four of them, and it is very interesting.